So 2000 BC and the Chaldeans determine a way to make eclipses predictable on a schedule. Well, this removes a lot of the fear associated with eclipses, and we want to describe and understand their observations and their calculations. Before we do that, let's review some of the terms that are going to be necessary to understand this, but that are so similar to each other, so we can make sure that we have all of these straight. And those terms include ellipse versus celestial equator versus ecliptic versus equinox versus eclipse. So they all sound very similar and they are related, but they are very different, and you need to know how they are different. This will come to you at a quiz near you sometime soon, in being able to understand the difference between these very important terms. First, to go back, what is an ellipse? Ellipse is a plane that intersects a cone, forming a closed curve. And we talk about cones a lot in astronomy, and we talk about points of light making a cone, and you'll hear about it again. We talk about gravitation and cones and so forth. So we will talk about this a bit, and the ellipse is the plane that we often refer to when we're talking about orbits. Okay? And we talk about a celestial equator, and I think that you can understand that that is related to the celestial sphere, which is like having a 360-degree planetarium around the Earth. All right, so the celestial sphere was devised by many ancient peoples universally around the world and independently to describe the night sky as a dome where everything was the same distance away. All the stars were the same distance away. The celestial equator was a part of that celestial sphere. It was the projection of the Earth's equator onto the dome. So in fact, it is the light blue in here. Here is the Earth's equator. If we project each point out to the dome, it would create this light blue plane, which is the celestial equator. All right. Now, the Earth is not perfectly spherical, so this projection is just slightly an oval ellipse. This projection of the celestial equator is halfway between the North Celestial Pole, the projection from the North Pole onto the top of the dome of the sphere, and it is halfway between that and the South Celestial Pole. So this celestial equator is an imaginary plane, and while many of the aspects of the celestial sphere, including the fact that all stars are the same distance away, while many of these aspects are false, this is our first scientific model, and it's still useful today for communicating observations in the sky, and in fact, in planetariums. So how does that celestial equator relate to another term that we hear, the ecliptic? We know that the celestial equator is that light blue plane that you see there, and you see this dashed line that seems to be in an ellipse as well, but the ellipse is horizontal, and this dashed line is known as the ecliptic. What is the ecliptic? The ecliptic actually has two definitions depending on how you look at things. Now, the way we use ecliptic is we say that this tilted Earth, and I'm going to use the same tilt that you're seeing. That's not the same tilt that you're seeing. That's the same tilt that you're seeing. So we are thinking about this rotating Earth on its tilted axis as revolving around the sun. And the ecliptic in those dashed lines are the projected movement in a horizontal plane of that revolution around the sun. So that if we projected this revolution out onto the dome, it would form a plane on the dome that is called the ecliptic. Another way to look at it is the apparent path of the sun over the year's time. And you can think about that when you think about your experience with the sun over the course of a year. Over the course of a year, you notice that during the winter, the sun seems to rise and set in a southerly location. And during the summer, the sun seems to rise and set in a more northerly location. Yes, it rises in the east, it sets in the west, but it can rise more to the south, it can rise more to the north. And when we look at that as an ancient person did, they would say that the earth is at the center of the universe and the sun is moving around the earth. Here's its southerly location in the winter, here's its northerly location in the summer. So that the ecliptic is the apparent path of the sun. That's the old way of thinking about it. We think of the ecliptic as the projected revolutionary path of the earth around the sun. You can look at this another way. Here is the earth rotating counterclockwise, and as it rotates counterclockwise, it is also rotating counterclockwise and moving around the moon, moving around the sun with a consistent tilt. As a result of that movement around the sun with the consistent tilt, that produces an apparent movement of the sun, which means that if you're not understanding the work of the universe, it seems that at the winter solstice, the sun seems more southerly to us, and during the summer solstice, the sun seems more northerly to us. And I just talked about that. And there are 2 days in between that northerly look at the sun and that southerly look at the sun when both poles, north and south, face the sun. And as they face the sun, that day when both poles face the sun equally is known as the equinox. And this is a day when pole to pole, the entire world gets relatively equal hours of sunlight. So, on this day, the equinox, the sun appears to be most direct over the equator. And in fact, this is the start of equal days and equal nights around this region of time, and moving toward the winter solstice when the sun will appear to be more directly over the southern hemisphere and days will become shorter in the northern hemisphere, the start of the winter season. There will be another time in March when both poles will be lit equally at the vernal equinox, and that is also a time when the sun seems to shine directly on the celestial equator. Now, what is an eclipse? Well, you know that the eclipse is the blocking of light, partially or totally, of one celestial body by another. And you know that an eclipse needs the earth, the moon, and the sun to align in order to occur. When these eclipses were random and seemingly unpredictable, they were terrifying. But once the cycles are understood, they can be predicted, and they can be less fearful. Eclipses have seasons too. So we just talked about seasons that were involved in the ecliptic. The ecliptic is also involved with the eclipse seasons. The eclipse season is when the moon's revolution crosses the Earth's ecliptic. Here's the Earth's ecliptic. It is the orbital path of the Earth around the sun, and the moon has its own version of its own ecliptic, but we don't call it that. We just say it's the moon's revolution around the Earth. And when those two revolutions meet up in a plane with the sun, then we call that an eclipse season. For instance, here the plane does not meet up with the Earth's plane. Here the plane does not meet up with the Earth's plane. Here we have a plane of the sunlight and a plane of the moon and a plane of the Earth meeting on the new moon and on the full moon. That's very favorable for an eclipse. In general, there are 2 times during the year when there is a meeting of the ecliptic of the Earth and the moon's revolution around the Earth. You may think this will happen right around the equinox. That is not the case. It just looks that way from this graphic. But there are generally, not always, but generally twice a year when the ecliptic lines up with the moon's revolution around the Earth. And that is called an eclipse season for that full moon and that new moon. We went over that. The Chaldeans made careful observations and measurements, and they came up with the Saros Cycle. It's phenomenal. And it basically looks at an eclipse as a predictable pattern that recurs about every 18 years. They could even get it down to the hours, 2000 BC. Amazing. And they were mostly looking at lunar eclipses. However, the Saros Cycle can also be used for solar eclipses. Let me give you an understanding. We start with 1. Here is a pattern of an eclipse in 1945. It went from about, I would say Oregon there, up over the northern pole, probably, came back around and into Asia. That was the first cycle that we're noting. Then, about 18 years later, the eclipse shifts about 120 degrees, and it started around Japan, 1963, went across the northern sector of Canada, and came in through Canada. It's the second time it appeared. Then it shifted another 120 degrees, and then that same eclipse started around the Mediterranean, went up over Siberia, and came back around to Japan. The fourth time is right around 1999, where you're seeing that it started off in the Atlantic, went over Europe, and came through to the Indian subcontinent. And then the fifth time it came around was in 2017, and that was the famous eclipse that went across the United States. This is one eclipse that recurs about 18 years with the cycle. That cycle can be noted here, the Saros number of 147 recurring in 17-year segments, and there is the next eclipse that we can see in June of 2021 that will be an annular solar eclipse. You can look at it here. We'll see it partially. Talk to you soon.